it's like the origin of all these. It's like the grandfather of all these pens in some
The
ways,
grand.
right?
This is the pen.
Yeah.
I don't know.
Uh,
I've brought another one actually. This is the other. Do you know this one?
I can't quite see it.
Yeah.
But,
Can we have the top view? Then we can. This is but it's similar for me. This is
the other classic.
Yeah, it's Tingy. Can we have the top view? It's a very classic. Yes, look. This is what I always had at home, but actually I couldn't find them online as easily as. I mean, I'm sure they are out there, but this is the pen that's everywhere.
I mean, this is like that is the pen. I'm trying to I don't really like the one that you shared. The other one you shared is I mean, it looks familiar. It looks like an archetypal pen, but I feel like the one that is like maybe more universal to me. I mean, this is like a paper mate one, but anyways, and then there's also, I mean, this multi-pen. I know we're going to talk about multi-pens, but this is another.
It's fun. We decided on another pen, but I have the exact same right here. Maybe we should do this one instead.
I mean, we could bonus content. We'll see it. We'll see how far.
Yeah, exactly. All right, let's take this thing apart. Where should we start?
Okay, I mean, I'm also I'm gonna just admit up front that I'm familiar with these pens, but I haven't done specific preparation. I think there's a lot of things that I expect to learn as we disassemble this, rather than I haven't gone into this with a ton of preconceived notions.
No, we're learning together. So the first thing, and it's also the thumbnail of the stream, is this tiny hole here. We can zoom in a little bit. Jum, 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 jum. And I was on, it's fun, if you search this pen on Wikipedia, the Bic Cristal, there's a paragraph or a sentence on Wikipedia about this hole, with a source in the Wayback Machine about frequently asked questions on the Bic side. And they answer what it's for, and it's to equalize the pressure, to make sure that it doesn't start leaking when it's in the sun or something, right? When the pressure goes up inside, that it doesn't leak out, the ink.
Interesting. Yeah.
But what and maybe you know why, I do not understand why they did not do this at the cap at the end.
Yeah, that's a good. I'm curious to pull the cap off and to look at it. I sometimes wonder if I mean, it looks like a secondary process. It's like a secondary drill hole.
Do you think?
I wonder if it's. I mean, maybe.
Shall we put it under the microscope?
Yeah.
Because I think.
I mean, I'm just imagining what the tool is that is producing these. I mean, they're injection molded plastic.
We can see, if you look at the tip here, you can see this white dot.
Yeah.
I think that's like the injection.
Injected site?
Yeah.
Wow.
I think so, at least.
I guess there's one on each side. That makes sense, yeah.
Yeah.
I need to grab my calipers from over there, but I'm curious to know if there's there's a draft angle on these. I'm also, I did notice as I just pulled this off that this one says Mexico. I don't know if you can see my.
Yes, I can see. Hopefully, I can see your. There we go. It's not sharp. Oh, that's interesting.
But Mexico, which is interesting. I guess it makes sense that they would have multiple. Multiple factories. This is such a ubiquitous. They make billions of these every year.
I have on mine. Maybe we can do the quad view. Yes, I have NH25.
What would you guess that means?
No idea. No, it's strange that yours said Mexico and mine has more like a serial number kind of thing. Like I would guess this is like about the whichever, like which machine made it or something like that.
Yeah.
Which batch.
Yeah. But so that hole.
To me, it looks like it's in the injection mold.
Yeah.
I cannot imagine that they did an extra operation on this for this hole.
I mean, they're so cheap. Yeah, it is like hard to imagine, I guess, that they would have, like, everything must be one shot. And that is like in many ways the beauty of, I mean, there's some objects in the world that are so amazingly cost engineered and like reliability engineered. You know, like the aluminum can, my Diet Coke out of.
Oh, yeah.
But this pen is like a perfect example of it. And they're unbelievably cheap.
Yeah.
So yeah, I think that like for that reason alone, you're probably right that there's no secondary operations. This is all things that are almost directly straight out of molds. And,
yeah. Well, one thing I'm curious too is that it is molded. Well, it's a straight thing, right? There's I would imagine, why not extrude this? You have the tip, of course. I can go back here. We have this tip that has a bit of an angle, but I imagine that you could just use this brown part and make it a little bit bigger, and then you have a perfectly straight piece of plastic that you could extrude. That I think that would be much cheaper than injection molding, but.
Well, I think that, I mean, there's the tapering at the tip, right? So that it would, if it was extruded, it would need some secondary.
Yeah, you would need to make this brown part bigger, I think.
Yeah, I think the. I mean, I actually think that injection molding seems like you could just get all of the features, all of the contouring, you know, even just like that Mexico label, all within the tool itself.
Yeah, that's a thing that you couldn't do with.
Yeah, so I think any kind of extrusion would require some kind of secondary steps. And I actually should have looked up, but you know, I think that the fewest number that I could buy when I bought this pen was 24. I bought like a 24 pack. That was, I mean, these are like cents, you know, it's like certainly, I don't know exactly, but it's less than 50 cents.
Yeah, I had the 50 pack and it was about around 50 cents.
Yeah,
it's crazy. Absolutely insane. Shall we open it up?
We should. Okay. The other thing I was going to observe, which I on the cap.
Oh yeah, on the cap.
The hole on the cap.
Ah yes.
Which I feel like I grew up with. I don't know if this is an urban legend or if this is just the truth. But that was explained to me as a safety precaution for if it was swallowed accidentally, that you could still breathe if it was trapped in your throat.
Yes, I heard that too, and it was also on this frequently asked question page of Bic itself.
Okay, maybe I should have done Wikipedia then. Yeah, great.
I was always surprised by this because as a kid, you have like markers and they dry out, right? So I always thought, like also for pens, like, oh, you need to put the cap on, otherwise it dries out. But that's not the case for pens. No. Pens are actually just they're airtight.
Ballpoint pens or roller ball pens. Yeah,
they are.
And this I think that this was the. I mean, I feel like there's probably going to be somebody who's watching this who has like a more encyclopedic knowledge about the history of pens in this specific one. So if you're watching the comments and there's someone who can correct me, then let me know.
Yeah, leave a comment.
My understanding is that this is the first, like, Bic bought the patent. You know, there was I think a Hungarian who invented the roller ball or the ballpoint, and Bic bought the patent. And this was the first kind of like mass-produced non-fountain pen, I guess.
Oh, nice.
Or at least Bic made the first one. Whether or not this was the exact design, it probably wasn't. Okay. What have you tried taking this apart yet?
No. Yes, accidentally. I noticed that I can just take this brown part. You can just pull it out with your fingers.
Oh yeah, look at that.
Yeah.
Wow, that's a nice fit.
Yeah,
that's so interesting. I wonder, do you think you can buy the refills of just the cartridge?
Probably. No, I don't think so.
Cheap.
Yeah.
Just interesting that it'd be so easy to remove. But even that,
yeah,
like that's
the
tolerances when you're making something that's so mass produced, and you're producing billions and billions of these every year, and to have a consistent kind of friction fit, honestly kind of blows my mind.
Yes, that's crazy. What I'm curious to, if we have a draft angle on the inside. There's no draft angle needed on the outside because it's like the two molds. Can we go to the top view? The two molds will be like this, right?
Yeah.
So because it's a hexagonal thing, it has built-in draft thingies. However, do you know how the inside is made?
Well, so I can also see, maybe it's just on mine that it's more visible, but there is a pretty clear like seam line that runs down one side and then the other side. It's like not coming up really on the
oh yeah. Can we get?
But there's kind of a clear part line. So
can you show it again?
Layered. Yeah. So I mean, I just see there's like a kind of white, very small flashing line that is kind of at the tip of my little thing, and then it's like repeated again on exactly the opposite side. It's just where the two halves of the mold part.
Yeah, right on the edge, right?
Yeah, exactly.
Right on the corner.
Okay, how did you get the little blue cap off?
I broke it.
Okay.
I just took my big pliers and nipped it off, so it broke a little bit. But I still think I can get an internal measurement if I tried really hard. Let's see. Something like that. And that is 6.05, 02, what's it? Okay, and on the other side?
Oops, oh yeah. I like fully shattered. Maybe that's what you did, but I...
Yeah, absolutely. The other side is significantly smaller. This tip side?
Yeah, so there must... Yeah.
But I'm not sure if it's just the end.
There must be some draft angle then, so it's like a... Yeah.
Because the tip angle is 4 millimeters, while the end is 6. But let me see if it's just this last part, or that it's actually... Like, I'm curious what it is here. Let's check.
Yeah.
This will not make a good measurement. Let's see how it goes.
Okay, I'm gonna get my calipers for a second.
Oh, but maybe we can see it from the... Maybe it's just so obvious that we can... Yes, it's just the end. I'm not sure if you can see this on camera, but it's...
Nice and shattered.
Yes. But you can see the internal reflections here, right? On the inside?
Yeah.
Yeah, so it's flat, and then on this end it goes narrow.
Huh. But I'm curious to see if there's a wall section difference at that, like right before it narrows, if it's the wall section gets... I mean, I don't know. Maybe it wouldn't have to get thicker at the bottom of the paper.
Yeah, but do you know how a mold like this works? Because I understand the two halves, of course, but how do you get the hole? You have to pull something out, right?
Yeah, so I mean, there's going to be like a form that's filling that negative space. That's in this case, it's probably just like a smaller diameter, kind of hexagonal rod that fills up that, fills up the exact interior volume of that piece. And so presumably, once the mold is closed up and it has like the two halves that creates the exterior form, and then from one end that pin slides all the way in and probably registers at the tip end with some part of the mold.
Yeah, it has to, right? Otherwise it would be crooked.
Yeah, and then gets injected from the tip end as you're kind of identifying those kind of sprue injection marks. That hollow cavity gets filled with the, I believe, polystyrene, and then kind of once it's cooled enough, that pin slides all the way out and the mold separates. And I would guess that this, because they're doing such an insane volume of this, that they're probably, the molds are probably set up to be injecting, like dozens of them at a time, or there's some kind of like auto feed cycle setup where they're just like
absolutely, they have to, right? Constantly
feeding more and more into it. So it's a pretty simple part. But it's obviously a very like high tolerant. I mean, it's a high precision part.
Well, and the fact that it comes out glossy, right? It comes out completely shiny.
So it's fun. I mean, you've probably seen some injection molding, kind of like
a little bit.
We've done some injection molding with clear parts, and it's kind of fascinating to see. The tool has to be so unbelievably smooth. They get like mirror polished, and so when you look at these molds, they like, it looks like this perfect faceted mirror, and that's just because that's has to be so smooth so that the surface comes out, optically clear.
Crazy.
Yeah, it's fun to see.
Shall we look at the other cap, like the end cap?
Yeah.
Because what surprises me, I bent it a little bit, but this doesn't look very hexagonal. Actually, let's go to the microscope because it's so small.
Okay, like I lost my end cap. I'm gonna crack open another one. Thankfully, we have multiple here.
we have. And it's, there's some writing inside. K55. That's fun. And we see it has these ridges on the side. Yeah. And they're not straight. And that's not just because this one is bent. They're actually like at an angle, I believe. If you look at the new one, let me get another one.
Yeah, I see. I got this one out pretty clean.
You can see that they are not straight.
Yeah.
Do you know why that is?
Like rifled.
Yeah.
It's a good. I would assume that is part of the strategy that is creating friction between this part and the barrel of the pen, and so the interior face of the interior shape of the body of the pen is this straight hexagon, so that there's six. There's like six corners going around it, and I think by probably making these slightly not straight, you kind of guarantee some kind of interference, so that you're registering those ridges to the interior corners of the hexagon, and then as you push it further in, they kind of like angle to these ridges, create some tension against the walls of the hexagon. I don't know if that kind of
makes sense. Makes sense. So it's like, like in this way they can put it in any way, and it will find the corners, basically, something like that.
Yeah, I guess I'm like, I want to verify that there are in fact six of them. Yeah, there's six.
1, 2, 3.
Do mine have
4, 5, 6.
writing on them.
It looks like 6.
I guess there's a little bit of some kind of serial numbering at the bottom there too. Got this one out relatively clean.
Oh, nice. I didn't.
I mean, that's so okay. So there's that blue end cap. There's the other blue end cap.
Oh yeah, the cap. The primary.
But and then there's the body. So there's basically 3 components that make up the body of the pen, and then there's I guess the cartridge is, I guess this gray, is this like a brown sleeve?
Oh, this brown part.
Yeah.
This.
So, I mean, it seems like, I don't know if I can remove that from the ink cartridge itself. And it seems like it's kind of over molded. It's like probably.
Oh, is it over molded, really?
I don't know.
I'm a bit scared to pull it apart, but.
Yeah, this is going to be, for the rest of the stream is going to be my hands covered in ink.
Yeah,
but,
but what we can see already.
Oh, I got it. Oh, I got ink too.
Oh, that
was good. It's only a little bit. Interesting. Okay, well, so the sleeve of the cartridge came off pretty easily.
What I'm surprised by. Oh yeah.
Yeah, I have a paper towel for just this purpose.
Oh, I totally forgot. I need to be careful.
Yeah.
I like these dots. Do you see these? These dots here on the side, and this one here.
I was looking intently at the screen, and I was like, I have one right in front of me. I do see the dots. Yeah.
Yeah. These are also for interference, right, or for friction?
Yeah, they must be. That's like what that. Yeah, that probably means you don't have to perfectly nail the diameter of the sleeve with the diameter of the kind of shell itself. It's like that. You kind of control that interference through those dots.
Here we see another injection site.
Yeah.
And, yeah, because like these dots, they make the interference less critical because they are weak, right? Because they are given enough friction, and they are quite small, so they can bend easily and that kind of stuff. So they can create the interference without jamming up the whole operation.
I just noticed on the rear side. So mine says Mexico on one side, but then on the other side there are numbers.
Oh, really?
It does say NG-01. So.
NG-01, because I had, I don't remember anyway, doesn't matter.
Yeah, okay.
Cool. Do we see anything else on this brown part, this tip?
There is
the logo.
So there's like a, I'll take the light away so if I can find something. So there's like the kind of ballpoint head. So I can focus this a little better. Is that focused? I don't know.
You can. I can show it. You just tell. I can.
Yeah, but so there's like the main taper, but then right before it gets to this barrel sleeve, there's like a small faceted.
Yeah.
Kind
it's 3 facets, right?
Yeah. Which I'm kind of curious how that sits inside of the. So it doesn't.
No, it doesn't sit inside. I saw it earlier. It's really strange. It sits on the edge. It can't go in. I have no idea what this is about. Possibly holding. It has to be, right?
Yeah, I guess so. Is that, what would that be? There's 3 of them.
Yeah.
Yeah, I mean, maybe it's some kind of for like assembly and holding. I don't know. I don't even know exactly. I mean, what's your theory exactly?
Yeah. I don't know.
Specifically, what's your theory?
Specifically, my guess would be holding,
yeah,
pulling out of the mold, or like when it comes, I'm not sure which direction the mold on this end, on this brown part goes, because here's the injection side. But I don't see any flashing. Yeah, on the end. On the.
I'm gonna try to take the ball metal tip out of here.
Let's see if we can zoom in a little bit. To me, it looks like there's some flashing here. Let me see if I can get this sharper. I don't know. Too small to see. What do you think? Is this flashing? What we see here on the edge?
Are you looking at the very back edge of it?
Yeah, here.
Yeah, I mean that makes sense. I think that's where there's going to be a seam between. I mean, this is going to be a similar molded part to the shell itself. So there's going to be some. I mean, you know, basically where the inside of the mold meets the outside of the mold, there's going to be some seam there, and that's.
This is actually one of the trickiest parts, I think, because it's hollow and it has a strong taper with a ridge. So like, it's how do I explain this? It's how would you mold this?
So I think this is a good question. So it's like when you mold a part that has like internal threads. This is I mean, this is actually kind of harder in some way, but my guess is that this plastic is just soft enough that even though there's that kind of
a lip,
like essentially lip that you have to pull the mold off of, like those divots, those little dimples that are creating that friction, seem like they would create interference when you're demolding it, but I think the material's soft enough, and the fact that it's hollow and thin walled, that you can still just slide it out of the mold. Unless it's, I guess maybe there's a two-part. I'm like trying to see if I see a seam running on it.
I don't see any seam.
Yeah, I mean, so I think that this is.
And on the tip, let me get that.
Okay, this is a good question. So I would. This is a kind of a guess here. I almost think that the kind of like seam line is like runs in this orientation. And so there's like a cavity that pulls off this way and a cavity that pulls off this way, and that like somewhere, you know, basically on the like inside that step is where the mold separates.
Yeah, you just ignore these little dimples. What's it called?
Yeah, and basically those slide.
Ignore those.
I mean, material's like soft enough that they slide out. Yeah, unsurprisingly,
something
I
like
have certainly.
It's fun. I wouldn't have expected that this was the most complex part.
Yeah.
Cool. Then there's a small. I think this is extruded, right? The actual ink cartridge thing. It has to be, right?
I would.
This little piece of plastic.
I think it must be. Yeah, and then
I do see some lines, but I don't think that's flashing. You see these? There are some lines. No, this is.
I don't really see lines on mine.
No, I think it's just scratching.
Yeah. I guess like one of the beauties to this, as compared to I think all the other ones that we have here, is that there's no moving parts.
Yeah, the bowl, but yeah. No.
I think it's like a nice. Oh, you have a little serial numbering.
Which is strange. I don't understand why they would do this. Yeah, I mean, maybe I do, but like, what do you think? Why? Because this is kind of tricky, right? To put a serial number on such a small little thing.
Yeah, I mean, I assume it's quality control. I think that, you know, they're. producing these at such high volume, and then if they realize that some batch of manufacturing kind of got through, and they're having issues with leaking or with any kind of quality.
Yeah, they can check back.
They can kind of trace it back and see, see what lot it came from and see if there's other lots that are affected nearby. And
I have one design question. Let's go back to the main cap. I do not understand at all why they would do the clip on the cap. So you have this clip, and then you try to clip it to something, and then right?
Yeah,
it's terrible.
Yeah, it feels like something that maybe just people expect, a pen to have a clip, and it just feels like this gesture to the archetype of what a pen is that isn't actually functional. It's like some vestigial tail type of thing.
It does work. I mean, if you're not stupid as I, like if you actually hold it at the cap, it works perfectly, and you can push it hard as you want. But yeah, I don't know. I would expect it in the end part.
Yeah. I mean, yeah, it does seem kind of short and stubby, and I'm not totally sure how good of a clip it is.
Need to get out. Yeah. Anyway, good. Shall we move on to the next one?
Yeah,
I think we learned some things.
That was a deeper dive.
Okay,
that was good.
Let me clean up a little bit.
Yeah. Gotta see if I can stop getting ink on my hands.
Yeah. These can go here. Back. Oh, I have one more fun fact. I was on this frequently asked question page of Bic, and they recommend. How do you think they recommend to store these pens?
They recommend you store the pens out of direct sunlight and horizontally.
With the tip up.
With the tip up?
Yeah. I did not exactly. I did not understand you. Like obviously, the ink is not running out, so like nothing happens. But
yeah,
I don't know why. I'm not exactly sure if they said that they don't recommend storing it with the tip down, or that they said storing with the tip up. I believe that they said we recommend storing it with the tip up. I couldn't find it on the modern side. This was on the Wayback Machine. There was no, on the modern Bic side, no mention of it. Anyway, let's move on to the next one.
Okay.
The Parker, right?
Yeah.
Let's look at the partner. Parker. Da-da-da. Somewhat less affordable. I paid, I think, $10 for mine. 8, something like that.
Mm-hmm.
And you?
Mine was, I mean, something, and this is a few weeks ago, and I don't fully remember, but something in that realm. I got a nice yellow one. Maybe I have, actually, I think, no, this is the one. I think I paid maybe $25, but I got 4 of them.
Oh, good deal.
Yeah.
Tingy, can you make my chat a bit wider?
Yeah, I've not been
you.
reading the chat. If you are, I hope you're. If there's anything of note, I'll trust that you can.
Yeah, we will get to some ink removal later on, and there's someone says something about the clip. The clip is a fidget toy in 90% of the cases.
I think that is absolutely that is absolutely correct.
Probably correct. Yes.
And it's like this whole. I mean, I'm like a big fidgeter, but just like testing the rigidity and testing where it kind of, reaches its limit of plastic deformation when it's going to stop returning to its own. Okay, the Parker.
Yeah, all my pens have broken clips unless they're from metal. Yeah, Parker, good pen, I believe. It writes. Oh, by the way, for those watching, this is not a pen review. We're really just looking at how it's made and the engineering and the design and that kind of stuff. We are not talking about how well they write or how they feel or that kind of stuff. We are much more into engineering and design.
I mean, the things that I could review are not things that most pen people would be interested in.
No.
Yeah.
Looks nice. Classic design.
Yeah, it is. Yeah, it's a nice. Yeah, I mean, I'm going to refrain from commenting on the design, but it's a nice design.
No, like you should comment on the design, but not on the feel. Right?
It's a nice compact size, I think. And a sleek kind of form.
What do you think of this finish?
It's a clicker pen. But so the finish, so on mine, the main body, I can't tell if these lights are helping or not. The main body is this nice yellow plastic. Like kind of the main sleeve, nice ink stain on my finger. The kind of rear side of it, where the kind of business end, all the clicking and grip area. This is all looks like a stamped sheet metal, like a brushed sheet metal.
But they brushed it afterwards, right?
I think so. That's what it seems like.
I really like on my pen, if we go to the microscope, you can't really see it with this lighting. Maybe the top view is better. And if we zoom in a little bit, you can see that it's really nice. That like they really tried to hide the seam of the, and I think for $10, they actually did a pretty good job. Right?
I mean, like on this camera and angle, I can barely see it. That's a pretty smooth, nice joint.
Yeah, but do they do this brushing on a lathe, or do you have any idea?
Yeah. It looks like it's I mean, it's like radially brushed. So it's like as it's spinning, there's some kind of like stationary, essentially Scotch-Brite wheel or pad that they use to brush it. And so you get those nice even little scuff marks that honestly just like end up hiding a lot of scratches if it's like too fine of a finish.
It also hides fingerprints, right?
Yeah, exactly.
Yeah.
So it feels like there's some messaging here that this is like a utility pen. This is like meant to be used and knocked around and not be too precious to me.
Yes. Yeah.
Okay, so
and it's a clicker pen.
It's a clicker pen. It's a nice click. It's a strong click.
It's a iconic click.
Yeah.
A double click.
Yeah.
So I'm curious what the mechanism is.
Okay, so there's the main body unscrews.
Do you know what I always like? When the pen is out, you can feel that it has a spring, but it's not heavy. And then you click it out, and then you feel both springs. Which tells us that there are 2 springs inside. Let's open it up.
There's a spring at the front and a spring at the rear.
I see a cartridge.
Yeah, I don't know enough about specific cartridges.
Oh, me neither.
But so this one has the built into the kind of rear of it, the stepping that allows. Maybe I do need the light on this.
Yeah, maybe bring the light back.
Yeah, that allows for the clicking.
These steps.
Into the,
yeah. I can show it better. I have a blue one, light blue.
And so there's a deep slot and a less deep slot, and so each time you press that clicker, it advances into the next slot, and then uses the kind of sawtooth, the radial sawtooth to yeah, kind of correctly advance it.
Yeah, I would love to see
if we
can.
Is that not your understanding?
Yes, but how it looks exactly, I'm very curious. Like, I hope to open it up far enough so that we can actually see that.
Yeah.
But
so the front body does have a spring at the tip of it.
Can you get it up?
It seems like it's captive in there to me somehow. It's like maybe it's connected to this little metal tip.
What I see is that there are multiple. Let me focus. It looks like multiple metal parts. Do you see this ridge here? Here.
Yeah.
It looks like there's an outer and an inner sleeve.
Okay, yours is. I mean, mine is one.
Ah, you have plastic, of course.
I got plastic. Yeah. So mine is like one molded part.
Let's look at the back then. I saw it here too on the inside. There's something in there that is a separate part.
Mm-hmm. Yes. I mean, yeah. Is there a sleeve? Yeah. I mean, I think that.
This looks plastic, right?
Yeah, it does look like there's a plastic sleeve, but it's hard to tell. It could just be like kind of a poorly. I mean, there's got to be some plastic parts in there, but.
Hey, do you see this?
How do we? No.
I can look inside.
Ah, yeah.
We can see the click mechanism, kind of.
Now I see. Okay. Can you? I mean, what happens if you press the plunger? Just it kind of extends forward.
I'm putting it up and down right now, so it doesn't do anything. Oh, interesting.
Yeah, so it's about how it kind of interacts with the end of the pen cartridge. That.
Oh, of course, this just goes up and down, and the cartridge turns.
Spins, yeah. I presume.
Shall we see if we can?
Yeah, take it apart.
Take it apart further.
Doesn't seem like it wants to unscrew anywhere.
No, I will put a plier on it. Pull. Right.
So you're just pulling the cap off.
Yeah, I at least want to get this the clip off.
I might take so presumably what this means is that it's press fit. You know, it's like somehow the cap is installed and it's rolled onto it. You know, it's like the metal has been shaped in the assembled position, or it's like stamped onto it so that the parts are permanently joined. I'm tempted to try to Dremel. I don't even know where to Dremel, but to kind of like.
Yeah, just from one side all the way on the length or so.
I guess. I mean, or is it? Do you do this kind of like around the perimeter of where it's?
I will continue with my pliers.
Okay, I'll try this.
You can.
So it's going to be a little bit of grinding sounding.
Yeah, Tingy will make sure that your audio is muted when you start grinding.
Okay.
Oh, it's not that bad. Okay, I have the tip out, or the clicker part. Yeah, that's good. Maybe go to the duo view thingy. I see some plastic inside. Maybe even a bit softer.
You have any luck?
Oh, that was quick. I have the clicker cap off, but that's about it. And you?
Well, I started to started to do a full bisection, and I realized it was going to be slow, and so I started then just trying to dissect the cap. I'll keep going with it.
All right.
I'll keep going with it for a second.
Can you do the sound a little bit softer, thingy? Oh, it's this is not the stream sound. I was worried for the stream for a second, but I still hear him. All right, that's another ring. Totally destroyed. This was part of the clip. So we have the clip and the thing. Yeah. I do think I need some. Just need to cut it open or somehow. Do you have any luck?
No. But I'm making progress. I'm seeing if I can avoid completely destroying it, but I'm not sure that I will be able to.
Oh, I have given up already. Yeah.
Yeah, this is destructive testing. This is like
absolutely.
Is there like somebody in the comments who's like yelling at us for how we should be doing this?
No, when Robert Jan says that the sound is fine,
okay.
And he said that the click end is screwed on probably, but that was wrong. It was yeah, looking at this, it was just molded over or formed over somehow. Okay, anyway, are you still making progress? Because I am not.
I'm not making a ton of progress. I think I'm mangling this. Let me try grinding for just like one more second here. Let me just see what happens.
Oh yeah. No, I don't see a good way to get into this, except for the Dremel. So I will wait for you to.
I mean, it's opening in a pretty mangled way here. I'm not sure that we're going to learn much from this.
No, probably there is a plastic part inside with some.
Yeah. Okay. So.
You have the clip and the tip.
So this is the. I mean, this feels like a work of art now.
Yeah, so as if it's run over by a car.
Yeah, perfect. So the cap is hollow, maybe unsurprisingly, and so as I was kind of gripping it, it's been mangled.
But it's nice. It almost looks like a rivet.
Yeah. So there is a plastic piece in here. But what is it doing?
Wow.
Can I even get it out? It's still fully seated within the... So there is a...
Hey, we can see something. A little bit.
A little bit. So this is looking in the mangled cap.
Yeah. Yeah, some shapes.
Yeah.
That's in. So you talked a little bit about molding internal threads. This would be very similar, of course.
Yeah. Yeah. If there's like an overhang or an underhang, I guess, for an interior mold.
How does that work?
Okay, I'm gonna grab a sample from my shelf real quick. Hold
Oh,
on a
sure.
second.
Yeah, I will draw what I imagine. Go to the top view. I imagine that it has to be something like you have. So let's say you want the part to be like that. And this is the part. I imagine that you'd have to make a metal that is like that, and another metal that is like that, with another piece in between that you can pull out. That's my guess. You get
Yes. So I think there's like 3 ways that you can do it. I mean, there's probably more than that, but there's 3 ways that I'm familiar with. One is exactly, it's like the hollow core, where like the teeth retract. So you pull out that middle pin once it's been molded, and then you can, retract all of the teeth on the inside, and then remove the cap.
Yeah.
The other way, which is very, very possible with threading, and maybe less so with like pen components, but the threading, you can often just unscrew it from the mold itself.
Of course. Yeah. That's so smart.
Yeah, and there's like tools that I've seen that have like they automatically unthread them, as they're part of their kind of like demolding process, which is like a kind of beautiful thing to see that.
And it has the added benefit that it makes any flashing or whatever, it removes that by rotating it around the mold. You get rid of any inconsistencies, right?
Yeah, and I mean, and the method that you were sketching, requires, if you're doing that radially, you have to have.
That makes.
You have to have a lot of different. You can still do it that way, but you have to have a lot of different sections, and they have to. Some of them retract, and then afterwards, other ones retract, and it.
Of course, it doesn't work at all radially. Yeah,
there's ways that you can do it, but it just gets complicated. But then, then there's kind of vertical seam lines that run through them. But then, with some very shallow threads or very coarse threads, you can almost basically just the material soften off, and the walls are thin enough that you can overcome the friction of those threads and just pop them out, and they kind of reform into their position.
Nice.
So.
Where were we with the with the pen?
It's like I think I need to further extract this somehow if we're going to actually understand what's going on.
No, we will.
I mean, I think that.
I think it's fine. Let's just look at your pen has also a clicker mechanism. We can use it. Look at that one.
Sure.
It's a little bit different, right? But I imagine a similar principle.
Yeah, the Kepler pen.
Yeah, shall we do that right now?
Sure. Yeah, so we designed, this is the first pen we designed. And it is, called the Kepler pen. And it's a pretty simple clicker ballpoint pen. And I think when we first set out, we make a lot of different home goods and desk accessories and kind of productivity tools, and pen is a kind of a natural extension for us. And it's like I'm a big analog sketcher and note taker, and I use a lot of pens. And
somehow,
pencils.
with all the digital technology, nothing beats a little pad.
Yeah, right? Yeah. There's no other apps to distract you on a pad of paper, so we set out maybe kind of naively to design a pen, and we wanted it to be like a less kind of like a carry around with you type of pen, and more of like a really planted at your desk. And this is like what you use when you're kind of getting organized for the day.
That is also why it doesn't have a clip, I assume.
Yep, exactly. Yeah.
I noticed it.
Yeah.
My table's not quite.
Yeah. You need to have a home for it. It has to have a. It's on flat. It's gonna be a problem. but the yeah, so we we kind of like identified the features. We basically wanted this to be as like simple, weighty, kind of have a nice click mechanism, not have too many bells and whistles, and just be kind of a nice tactile writing tool. And we started by naively being like, we're going to design like our own mechanism. We're going to like look at all of these clicker mechanisms that have existed and that have, there's like technical drawings and different patent archives that you can look up. I mean, Google patent, by the way, is like an amazing resource. There's a fantastic engineering learnings over like the last several hundred years. They're all very beautifully documented patents. But so yeah, we were like, we're going to try to design our own mechanism and try to design our own kind of interaction. And I think we spent a couple weeks working on that, and we're very humbled very quickly about the complexity of getting that kind of click mechanism right. And
so we'll take a look inside.
Yeah. So it's pretty simple to disassemble. There's not going to be dremeling or but so yeah, just unscrews. The plunger unscrews, and basically all of the guts of the pen slide out. And so we decided to use, after trying to do this ourselves, we decided very quickly to use off-the-shelf components, and so we used the Schmidt refill and a Schmidt kind of clicker mechanism.
Yeah.
And this specific mechanism was so nice to us because it was basically all of the kind of like action of the pen happens in this one mechanism. So basically
there's no front spring, right? That's
and so that was a big thing for us, is we're trying to figure out how to not have basically have this one unibody kind of seamless design.
Two parts,
which is what we achieved. Exactly. And so it's like the main shell that, there's a like some important stuff happening along the interior of that, and then basically the plunger itself. And so both the ink cartridge and the plunger are actually just press fit into this mechanism. So this mechanism is
the ink cartridge and the
you can
plunger?
Just pull it right out. Yeah, they're both just friction fit in there.
And the plunger is this. That's nice.
Yeah. And so that was
just a little part.
Yeah, because most of the kind of clicker pen assemblies require two springs, like one spring at the tip that is.
This is surprisingly elegant and small. This clicker mechanism. This is all the moving parts of the pen.
That's all the moving parts. That's like all the brains of it. Yeah.
Amazing.
Which is not, and again, so I think once we discovered this, and we kind of discovered the Schmidt catalog, and they have so many kind of variations of very precise mechanisms, it was very easy for us to decide that we're not going to try to reinvent a mechanism on our first pen, at least.
Cool. And how does this work? Can we take this apart?
We can take it apart. It's going to be, it's definitely going to be a destructive process.
Okay, let's first take it under the microscope, because what can we see? I see a small a pathway, right? For something to ride in. So it is pushed. I'm just thinking out loud and see if I can deduce from the information I have here. So there's a spring pushes this metal part out. There must be something inside of that metal part that rides in this groove.
Yeah.
And when you push it up, it goes there, and this goes all the way around, I think.
I think so.
Huh? No, it doesn't. That's strange.
Does it not? Well, I think it's part of it might be.
Maybe it should. Maybe it does.
Underneath?
But because look, here is a straight bit with a dimple here to keep it from rotating. Interesting.
So, and yeah, and I'll admit that it's been a while since I've disassembled one of these fully, but I mean, I believe I understand. I have disassembled several of them.
Okay. Yeah, I'm curious about this this ditch here, because this one needs to cross it, I believe, somehow.
Yeah.
I'm curious. Let's open it up.
Yeah. Let's open it up. I mean, so yeah, and the interesting thing that was on the surface of it confusing to me initially was that there's no obvious rotating. I feel like with most kind of traditional clicker mechanisms, like on the jotter we were just looking at, where there's the kind of like sawtooth pattern, the ink cartridge in that case rotates as you click it.
Yeah.
And there's other examples where some other mechanism in the butt of the pen will rotate, but there's no obvious rotation that's happening.
Yes,
here.
like this looks very nice. Also, I have no idea how to take it apart, because like
yeah,
I don't.
So
I
think that you may be able to squeeze the two black prongs together.
Yeah.
So there's like a gap in there. So I think if you use your pliers and squeeze those together, you may be able to slide the brass sleeve out. Maybe is the kind of critical descriptor. Yeah. I believe there's a ball.
Oh, a ball.
Maybe you will reveal something.
Okay, now it went back in because I couldn't pull it out. Oh, I have to have it in this orientation. This is strange. Yes, something. I just need to pull harder, I think. I don't want to destroy it.
I think that you may sadly destroy it, but
this is what it is.
I'll send you another one.
That's fine. Almost. Aye. Not quite. Are you taking one apart too?
Yeah, I'm going to take mine apart.
Because I have it quite far, but the last bit is still stuck again. Oh, I see a little ball. Indeed. Does it come out? No. Oh, that's interesting.
Yeah, I have popped one out before. Maybe it's
if we go to the microscope.
Yeah, this.
Ta-da!
So it's riding in this channel.
There's a little ball there.
So that is going to ride. I mean, it's funny. It's a complex little path that it follows, right?
I think I'll just break it. No, I don't want to break it, but like, because I want to see how it. Yeah, it's quite a complex path. Wow.
And so there's this ball that is within a channel. So the ball can rotate around.
Got it.
Yeah, nice.
Good. Then we have a spring. We have this metal thing. Is that ball stuck? Like, is that ball? No, it can move.
It should. It should be able to pop out. I don't think it's captivating, but it might be.
Maybe it's just grease.
Require a little bit of. Yeah,
it's not moving.
But mine is also currently still in there.
Oh, I think it's out. It's on the paper. Is it one ball or two?
So there's a little ball. Oops, mine just fell out.
Yeah.
I think it's just one ball, is my understanding.
Okay.
I think I lost my ball.
Oh yeah, I see. It's also just one groove. Let's go to the microscope. So what exactly happens here? Let's focus. So the ball comes...
It's like, I mean, it's like kind of a shockingly complex path. But so I think that there's clicking, like depressing it and retracting it twice, I think completes a full circuit of this, I believe, a full circuit of this path. And so you can kind of tell that, like, I wonder if you like imagine that you're like following this first path, you know, and you depress the pen and then the ball travels up to here. And then,
wow.
Yeah.
This is awesome. So this is such a cool path.
Yeah, it's like it's not totally clear to me why it has this kind of like double path to it, and I'm like kind of curious to. I'm sure there's some documentation out there as to why it. I mean, it seems to me it does a full loop, like travels the full path with 2 cycles of kind of depressing and retracting, depressing, retracting. But because the ball is what moves inside of the groove, it allows, the kind of full assembly to be very stationary. It's just like the horizontal movement that happens when you press it.
I am trying to figure out this path, but I cannot. Because this is the orientation, right? You push it down.
And then so that's in like you're writing with the pen. The pen is extracted from the.
No, but like you push it down and then it goes like to here or something, and you are writing, and then you push it again, and it goes back to. But then I don't understand why this little thingy, this little path is there. You know, this makes sense. Press once, it stays here. Press twice, it goes back down again.
I wish that I had I mean, I wonder if this. I don't know. I honestly, I mean, I feel like this is the mechanism that we chose, and we chose it for this kind of how concise it was. It took all of the complex parts, and it didn't require us to have like a spring in the tip and have like a removable tip. It didn't require us to. It basically just made the design process so much simpler. And when you find like an off-the-shelf existing engineering that is reliable, then you know the like comparative lift to try to create your own version of it is just often not worth it. But now I want to know. Now I wish I had.
Can you contact them? You have contacts there, right?
Yeah. We have a really great like sales rep, which I'm sure like will send us some documentation. Or
send a timestamp or a picture and like, hey, what's this about? Cool.
Yeah.
Awesome. Yeah, smart with just a tiny ball bearing, half captive, like captive in one direction. And then because I was wondering like why does it not? Why does nothing rotate? Normally you always see these things rotate and need multiple springs and
it's also it's the one plastic part, you know, it's in some ways the maybe the most complex part, but it is the one plastic part.
They did an amazing design job. Like a design review of this this click mechanism, 10 out of 10.
10 out of 10, Schmidt. You guys killed it.
They killed it. I'm curious, the body of your pen, because the what did you call it? The plunger?
Yeah, I call it the plunger. But
it seems easy enough. I'm curious what kind of operations you need to make this, because there's threads inside. It's smaller on this side with a very precise hole. Do you know like how exactly they make these?
Yeah, we've been to the factory a few times. They do, so there's a lot of pen parts, you know, kind of nicer pen parts that are made on, I mean, a lot of them are made on kind of advanced CNC lathes, CNC machines, but ours is made on some old Swiss screw machines, which are very precise, kind of like repeater lathes, almost like they can do multiple operations, like that are pre-programmed in a kind of manual way, not digitally controlled necessarily. I think that their first use case was probably making like clock parts, like small wristwatch.
So it's like a manual, repeatable lathe.
Yeah, programming lathe. Yeah, exactly.
Cool.
And there's a couple operations, but it's milled out of solid bar stock, and that's why it's pretty heavy. And it's I mean, I wonder if I could draw the wall section. I don't know if I can do this while I show the screen, but very.
I'm curious what you're drawing.
Yeah, this is what I'm doing.
The suspense
here.
Meanwhile,
so very coarsely here. You know, there's basically multiple steps down where it's a much wider bore at the rear end, and then you have this threaded section that's actually closer to the middle than it is to the end, and that's what the brass part of the Schmidt mechanism screws into.
Yeah.
And then it narrows slightly in the kind of part of the barrel that's around the cartridge, and then it narrows to its like kind of final diameter right at the tip, and that tip opening is like a pretty critical tolerance. The kind
super
of
critical. Yeah, it's like if you look at it. Wait, let me show the microscope. See if I can focus on it. This is exactly in the middle. Like the amount that this is in the middle is like staggering.
Yeah, and then the diameter difference, you know, basically you have to have the right, on the inside diameter, the kind of right tolerance and distance between that external diameter and then the diameter of the refill itself, so that there's enough gap that it can slide in and out without any real friction. But then once it's extended, there's not going to be any real movement in the pen tip. So
you want it to be responsive when writing. You don't want it to slop around without.
Yeah, and that was like another learning when the first couple samples. I think we did not highlight that diameter was as kind of tight of a tolerance as it needed to be. And
but so how does this work to get a hole so precise at the end of a pretty long piece of stock? Like, how do you hold it? What kind of drill do you use? Because if I imagine doing this, even with like, I don't know, the most stiff drill you could possibly imagine, it will wander all around. Yeah,
and I think the deep boring is there's like always going to be some drift, and it's going to get off center even with the most advanced. So we actually ended up the final kind of like this gap opening, we actually drilled from the opposite side.
All right.
To kind of eliminate the potential of that drift over.
That's the trick.
4.5 inches. Yeah, that's the trick. It's not a very clever trick, but that's the trick.
And then you do the inside first and then the outside?
The inside is figured out first, and then we kind of like use the inner walls of the inside to both hold it and make sure that it's like centered as we are.
That's
like
the trick.
Cutting the
I understand.
And so the first steps are mostly done on these Swiss screw machines, and then the exterior shape is done on a CNC lathe.
Okay. Yeah. Nice.
But
cool.
Yeah, I think there's I think as we got further into it, it's many realms of I don't know, manufacturing and design that have rich histories is that there's a lot of complex engineering and a lot of smart people who came before who figured out a lot of things. And
Yes.
when we started to try to do this ourselves, we realized that we needed to borrow as much as possible from existing people's work.
No, but like this is nice. And did you see my improvement?
I did, yeah.
A little piece of tape.
That was good. It really removed any kind of movement within the plunger.
Yeah, yeah. Is that something you came across in the process of making it? Like the little bit of rattling, or?
Yeah, I think that. I mean, there was a lot of fine tuning of the. It's like a fairly long plunger, and that's like for a couple of reasons. One is that we wanted it to have, like, there was a second type of mechanism that we could have used that accommodated a slightly longer cartridge. But yeah, we decided to use this one because it allowed essentially to have this like solid mass, and it kind of pulls a lot of the weight a little bit further back in the pen.
Yeah.
And the pen is pretty heavy, compared to a lot of pens.
Definitely.
And that was like to some degree personal preference, but like I don't like it when the pen, like if you see with the cross section, it's like there is going to be a lot more kind of like meat that is in the front of the pen, and so it's going to be a little bit more front heavy, and we wanted to counterbalance that with the plunger towards the rear.
Yeah.
Which I think just makes it sit a little bit nicer in my hand at least.
Cool.
Yeah.
Nice. Okay. Shall we move on to the next?
Yeah. I just realized, I'm like, wow, we're really getting into
I think it's time for some specialty pens.
Let's do it.
Maybe we don't get to the tornado. Let's see how it goes. We have the cheap, or the relatively cheap, multi-pen. This is 4 and 1. It's 4 pens and 1. What is it? Pencil?
Yeah, pencil. Yeah, it's 4 and 1. I thought it was 4 in 1, but it's 4 and 1.
No, and the Rotring, or the Rotring, or however you. This is 3 in 1. It has 3.
It was 3 in 1. Yeah.
Yeah. Shall we start with the Rotring?
Sure.
Because I like that one best. It's just.
I do too.
When I saw it, I was absolutely amazed. Like you rotate it, and it has multiple things coming out. Just amazing.
Yeah, I mean, I think the mechanism on the Jetstream, the 4 and 1, is very familiar. It's like the same as the kind of classic doctor kind of medical pen. But I think that the mechanism on the Rotring seems more. I'm more interested to investigate and understand it.
Yeah. Right. Let me check what it does. So we have 3 things, 3 cartridges that it switches between. But one of the cartridges is a mechanical pencil.
Yeah.
And that just works by clicking it. So you click hard. What I'm curious to, if I have another pen out, right, I need to take the mechanical pencil, and there's something coming out. And then I go to black, and I press on the end to make the mechanical pencil come out. Let's see if it actually did something. No, it does not come out when it's not.
That's a pretty clever one.
Yeah, right. That's curious.
So from a, I mean, okay, I know we're not reviewing pens here, but like from a build quality, this is very much up my alley. These Rotring pens are just, it's like solid steel and has this knurled grip, and
it feels.
I'm also biased. So I started architecture in school, and my advisor, who was my mentor and who I really looked up to, used a Rotring mechanical pencil, and I think I observed it, and I just like understood that those. I think I have one right here. I have like several of them floating around. It's the same kind of aesthetic and design.
Yeah.
But
Sick.
This is just like what is a technical drawing tool. This is like what it is to me. So I'm biased towards them. And they're very matte, like kind of metallic finish.
Yeah, yeah. As soon as I picked it up, I knew like, oh, this is like the what people think of when they think of German engineering.
Yeah,
like
yeah.
Strong and heavy and nice, like very precise. Is the knurling any good?
Yeah, this is very good, very fine knurling.
Yeah, it's very fine.
Yeah.
And is it a bit even and stuff?
I don't see any weird breaks to it. It looks like a well executed knurl.
Yeah, yeah, on both sides.
And this is like this is more within my, I mean, to some degree within my wheelhouse. I feel like I understand metal construction a little bit better than I do plastic construction. We've done some plastic parts, and should we crack this open? Should we figure out how this works?
Yeah, let's open it up. Are there any super chats, Tingy?
Any what?
All the purple ones super chat. That's nice. Yeah, I'm just checking the chat if there's anything you have to. There's one question from Jeff. Do you have to retract the mechanical pencil part before swapping pens? Also, does it work like those 4-color 2 pens only with rotating mechanism inside? Well, that's what we're going to find out. And I believe you don't have to retract the mechanical pencil to change. You can just change and it will break if it's too long, but whatever. Yeah, all right, let's open it up.
I'm gonna pull it back.
So the tip is very simple, it seems. Just screws off, nothing inside. And on the side of the pen, this is where everything happens. Oh, this looks nice. Oh, I'm just gonna enjoy this a little bit. Oh my God.
It's like pistons firing or something.
Yeah, amazing.
It's interesting. So yours unscrews right there. I don't.
Do you have a different mechanism?
So it's not readily unscrewing there, which is interesting. But it does pull out from the rear. Does yours also pull out from the rear?
What? Pull out from the rear?
You just pull that backwards. Do you get so?
Do we have a different one?
Maybe. So what is okay? Let's compare models here. Is yours the Rotring 600 3-in-1?
Yeah.
Very interesting.
Yeah. But can you show on the microscope what you did?
So I just
oh wow,
pulling.
Yeah, got it. Just needed to pull harder.
I have a second one of these pens here. Let me just see if this one unscrews. Maybe it's just like a.
Yeah, the tip unscrews.
Oh wait, this one does unscrew. This one does. This one is just really tight.
Cool.
Interesting.
Yeah, okay. So it's just an outer sleeve that feels really good, and it's just a simple sleeve. I saw something clever already. I talked about like how the mechanical pencil doesn't work when it's inside. Mm-hmm. That is, let me put it on under the. I think, look, this needs to be pushed in for the mechanical pencil to go out, but it has nothing to push against right now. So I think that in the tip, when it's out, let me see if this works. I just press it together. Yeah, cool. So it rests here on this little lip. And then it works. If I just do that. Very smart engineering. I love it.
Yeah.
You love to see it.
It's yeah, I have there's like I have like mixed feelings about I think multi-pens are actually really like useful in many cases, and like I there's periods of my life where I've gone through like note taking that's color coordinated. There's something that's like a little bit hard for me to buy into about having a mechanical pencil with a multi-pen. I know that it does allow you. It's like in theory, this is the one tool you need, and this does a good job of kind of like getting a pencil and 2 ink cartridges into it. Honestly, a very slim body. Like this is not this. You know, this is. It doesn't seem like chunkier. Like oftentimes you feel like multi-pens are these really beefy, you know, bodies, and this actually feels like a generously sized single cartridge pen.
Yeah, it's not super. Yeah, if you look at this one, or where's the other one we had? I lost it. Oh, here.
The foreign one. Yeah.
Yeah, it's super big compared to a normal pen.
Yeah.
Well, this Rotring, but it's also 3, right, and not 4 or 6 or 5 or whatever.
Yeah, yeah.
Yeah, but I think that was the right choice, I think.
Yeah. I also assumed that this end cap was containing a eraser, which I don't think that it is.
No.
I have like their mechanical pencils. You know, this is like one of the Rotring mechanical pencils, and this little piece pops off to reveal a eraser. Nice. So it doesn't seem like it pops off to...
No, I don't think so. How can we open this? That's the question.
Yeah.
I think we need to Dremel, because do you see this? It's like properly pushed on permanently.
Stamped in there.
Yeah.
Huh. This is the first one that I feel like a little bit bad destroying, but I think we have to destroy it.
Yeah. This is... Oh, how does the changing out? Yeah, it just comes out the fill. The fills. Okay, let me get a new Dremel cutting wheel, and I'll see if I can try to carve this one open. Yeah, but how? But how? Yeah, I'm thinking maybe cutting this part off, like this hole.
Yeah.
Drilling that out or something.
So
I can also try with my Dremel.
Okay. Yeah. I mean, there's 2 sleeves here, right? There's like there's the silver colored lower metal sleeve.
And that rotates.
That rotates, and then everything else is fixed. You know, as I'm rotating.
The tip rotates too. The very tip, right?
Yeah. So it's like all one solid connection. I'm trying to like hypothesize what does that teach us? I mean, you can imagine that there's some similar kind of sawtooth thing happening, you know, where there's kind of like one location at the tip that has a lower saw, or maybe it's not a sawtooth, a lower kind of like wedge, and as you rotate this around, it deploys a different one.
All right. Let's see. Yeah. Maybe the sound should be a little bit lower. All right, that was easy, I think.
Did that release something?
Well, that's I don't I don't know yet.
To be determined.
To be determined. Oh my god!
Is it hot?
Dust. A little bit, not too bad. Sorry, I was in the camera.
Isn't it fun to be doing this as a live stream? First time ever.
I hope they like it.
Yeah.
I don't see this moving. I hope it's not glued. That would be bad. I need a pair of pliers to pull.
I'm gonna get my other Dremel.
Don't have enough grip. Yes, got it. I got something at least. There's still, is there something inside? Let's look under the microscope.
Did you learn anything?
Yeah, well, I got it open.
Oh yeah, look at that. Beautiful.
And I was just trying to look inside with the microscope, but can't really see anything. Yeah, plastic piece with some kind of shape. Let's look at this.
Okay.
Oh, well. I imagine this some kind of shape is actually quite important if I look at this. So can we zoom in a little bit? We see very long springs here, extremely thin and long. Some kind of pointy bit here on the side. This must ride in some kind of groove and be pressed down by rotating it, right?
Yeah. I mean, that must be
something like that.
Okay. I'm gonna see. I should have thought this earlier. Somewhere there's a box in my office. I have a bunch of different mechanism. We bought all these different mechanisms from Schmidt.
Oh, cool.
I wonder if I have one that is a multi-pen.
I launched it.
Did you lose a spring?
No, I have it back, but almost.
Okay,
they're all captive except one, so I almost launched it.
Yeah.
But yeah, that must be it. Let's see if I can.
And it'll be back in 20 seconds.
Yeah, sure. We will investigate further. Interesting is that this doesn't, like the very tip doesn't do anything. Completely stuck. And looks like there is some plastic here. And I want to push it out. Let's get the end of a pen. Because it did move, apparently. Yeah. It moves a little bit. Feels like I should be able to push it out. No. Not really. Oh! Yeah, no, I need to open this up. From... Huh. Okay, yeah, I will just... More dremeling. So be careful with the noise. Ow.
Nice and hot.
Yeah. Yeah, nice knot. Now let's see and pry it open.
Mm-hmm.
Yes, I can see something. I will cut my fingers if I'm not careful. Look, there is some kind of plastic shape in here. Oh, it's stuck. Let's see if I can.
Yeah, it seems like they apparently don't design these to be easily fully disassembled.
No. Okay. Almost. Yeah, there we go. I just need to smash it.
Yeah, I did find some Schmidt mechanism samples, but they're like fully. They're not going to tell us anything.
Yeah,
like
look at it.
Already assembled.
I have it. Yes, there it goes. Okay.
Okay.
So, what do we have here? Oh, this did screw on the end. This but I tried unscrewing it. It did not want to come off. Okay, and then we have a small metal part, which I don't know the use. And then just this shape. So let me get this here. This sits like that, and just, it's a bit stuck, but this just pushes them down, right? Like
yeah. That. Wow. That is, I mean,
super simple.
Yeah, that's a surprisingly simple, but and that's like a steep angle for it to be pushing on. But it seems that they got it to work. That's great.
Yeah,
that's cool. That was effective. I didn't expect you to actually figure it out through disassembly, but you did that. That was great.
This is way steeper than I would think.
Yeah, I mean, I think it's like the plastic, so
it has to be super
slippery.
low friction plastic.
Yeah. And the little like corresponding cap on the end of the spring seems like it's angled to kind of slide on it nicely.
Yeah. Yeah. Do you see the angle change? Like this is steeper than this.
Interesting.
Yeah, Jeff was right. I just see a super chat come in. Does the cap freely rotate or is it threaded? Well, it turns out the cap was threaded. But I couldn't.
I took some pliers too, and I managed to unthread mine. And it does. I mean, just when you discovered that, but it does have some. I think it's some nylon. It looks like it had some thread lock, some nylon thread locking. There's something that it wasn't intended to be disassembled.
If we look under the microscope here, you can see the angle change. And this will be all about the feeling of, mine is broken now, but if you rotate yours, you can feel that it's not smooth all the way. Like you obviously start somewhere, then you feel resistance, but halfway through there is a change in how hard it is, right?
Yeah, and I mean the feeling is that when one of the three cartridges are extended, it really clicks into place there, and then it takes a good amount of force to kind of overcome that, and then it becomes a little easier, and then as you get close to the next one, it kind of sucks it in.
Yeah.
Does that make sense?
Yes, absolutely. But do you know what I completely cut off, right? I cut exactly on the tip. I imagine that there's some kind of thing that it slots into. Right? It has to stop somewhere. It has to stop at the right moment.
But I wonder if the So that plunger, I mean, there's 3 of those plungers, right? 3 of those spring
yeah.
plungers. And so those are on the opposite side to what is actually being deployed. Is that right?
So like the opposite side of what's actually being deployed?
When one of those springs is like nested in the back, in the topmost part there.
Yeah, like this?
Yeah, so then in that position, whatever that spring is connected to will be retracted. It won't be. It won't be
like when it's on the tip, it is.
That's when it's,
when it's working. So on the tip, I think I cut it off, but there has to be some kind of, let's see if I can focus a bit better. I expect that it was like this with a V, right? With a little notch to rest in.
And so if you put that sleeve back on with, with one of the plungers like in the highest spot in the
out position, the stupid thing is I broke it, right?
Yeah.
I cut it exactly in the wrong part.
Or I guess meant in the opposite. So if you put one of the plungers on the
like
low
this
side, okay. So is it 2 of them nest in there? And then one. Okay, I understand. Like, okay.
One is there are 2 on the lowest point, roughly.
And so as you rotate it, you're pushing one out, and then the other one is coming back, and then the third one is not being engaged.
Yeah.
That's pretty clever.
Oh, so you also use the force. Look, if you want to try get one up, the other one comes down.
Yeah.
And that one pushes to help rotate this whole contraption. Otherwise, it would be much heavier, I think.
But yeah, and the shaping of that slope, that kind of like, the fact that it's not a straight slope, that it has that kind of S-curve.
Yeah, that's strange, right?
That's just, I mean, it must just be about the kind of hand feel, about how it how much force it takes to overcome it, and how it kind of pulls itself in at the very end to the next groove. It's cool to see that kind of like tactility programming,
in a physical way.
Yeah, exactly.
Yeah.
It's kind of beautiful.
Awesome. This is really
it's pretty nice.
I really like this one.
Yeah. I didn't want to pick favorites, but I have a favorite. That's this one. Good work disassembling that. I just set up my Dremel with the next like bigger cutting bit, and I was like, I hope Aldo figures this one out.
Yeah. Shall we take a quick look at this last multi-pen? This is a very simple one, and then I think it's time to wrap up.
Yeah.
So this is...
Thank you for destroying that one. Okay, so that was the 3-in-1, and this is the 4-and-1.
Yeah.
Yeah.
So this just bends. There's just a inside of here is just nothing. It's just smooth with a funnel to the end. So this just bends to the middle, whatever. So all the interesting things. Well, that was interesting, of course. It's such a simple solution. But I'm curious how it sticks. So you push it down, and then it sticks. And as soon as you do the other, it releases.
Yeah.
I'm curious how that works.
And the thing that is also interesting, and I can't quite figure out if I like this decision or not, but the clip itself is one of the plungers, and that is the
pencil.
The pencil?
Yeah.
And that it doesn't, seemingly, I can't, at least without the cap on, I can't retract it easily. I guess I have to press on the clip itself.
Oh, that's strange. Yeah, all the other ones go back if you, as soon as you start pushing a second one. but the pencil doesn't. That's strange. Huh?
Okay, so the cap is an eraser. I'm like looking for seams. I'm looking for places that this is easy to disassemble, and I'm not sure that there are.
Yeah.
There is like a seam running around the.
Yeah, there's a
There's a seam that's running around that perimeter, but it doesn't. I can't. That might just be a part line or like a moving line. I don't know if that is that moving for you.
No, I'm trying my best, but
yeah,
I think we have to go destructive on this one too.
Okay.
Which is fine. I'm not so high on this one. It feels very cheap and bad. And then they have the worst decision they could possibly make. Like this sticker.
Yeah.
Like semi-permanent with the barcode. Like it's so tacky.
Yeah.
We are doing a review now, but that is that's my review. That was you can take it
personal
off, I guess.
personal preference.
Yeah, it feels very cheap.
Yeah.
Even though it wasn't, right? I think it was for $30 or something for this one, or 20. I'm not sure.
I don't.
Exactly.
Yeah. Okay, we're gonna cut this guy open.
Yes. Let me pull. Here are the cartridges. If I have the cartridges out, it still works exactly the same. Okay. We can see a few holes.
Yeah, the kind of like rifle barrel, or like a revolver.
Revolver thing, yeah.
Yeah.
Like it. I will just smoosh it. I'll take my. Okay, we have some threads. I will just nibble away at this. Can we zoom out a little bit?
I'm gonna do some exploratory dremeling here, so you can. You can mute me if it's.
Yeah. I'll be. This feels like clipping the nails of my goats.
Yeah.
Here we have the rifle thing. Let's continue. Hey, something flew. Mine flew apart like a cartoon thing with like 5 springs coming out. And this white barrel part.
You caught it all, it seems like.
Right. It's so strange that this pencil thing is very different. I don't know why they did that. It could just be the same, it feels.
Yeah, so I mean, this is kind of what I was. I mean, I think that the Rotring pulls it off pretty well, but I feel like including a pencil in a multi-pen is a nice marketing statement.
Yeah, if you want to do everything with your pen, it's nice to have a pencil.
But it's not my. It feels like a. Just I don't know. Something about it feels like like very complicated additional features. Like making a mechanical pencil is in many ways much more complex than making a pen.
For sure. Okay, things are falling out, but I'm not any wiser about how this works. Did you have any luck with the Dremel?
I mean, I cut the rear off, and the plastic kind of melted a little bit, but I got one of these clips out. I think that honestly, it's like the shape of this clip that is doing a lot of the interesting mechanical work. I mean, it's obviously nesting into.
Oh yeah.
Nesting into some kind of like.
Can you show that again?
Form. Yeah, I mean, so I was holding up to my main camera here, but it's like that interface. I mean, I can put it on the microscope. It's a little bit clearer.
Yeah.
The profile of that interface.
Can we go to Hunter's microscope? Yeah, I see that profile too on the other clips. Something interesting is happening there.
Yeah, it descends to a point within there that, within like the center of the body, that it can essentially click inwards and underneath one of these levels. And whenever a different plunger descends, there's some part of this profile that essentially pushes the opposite ones out.
Yeah.
But it is a bit finicky feeling.
Yeah, I'm continuing
I'm gonna dremeling.
I think we're almost there. Yes. I'm in. All right. I can see some stuff, I think. Maybe I can kind of put it together even and see how this should work. Yes. I love it. I'm having a blast.
You can tell that was like sarcastic or if that was just, yeah.
I have like Jeff is helping like immensely in the comments in the chat, but I'm constantly too late. Like he says amazing stuff and then I read it when I destroyed the pen. I'm sorry, Jeff. Okay, so
I mean, these are surprising. These plungers are surprisingly complex little injection molded pieces.
Yeah.
I mean, maybe it's not surprising, but there's a lot going on.
I was in. Let me put this under the microscope. I think I have something that we might be able to see. Look, I have a plunger and a side profile. Can you see this?
Yeah.
So
there's like there's wings on the side of it that are like sliding within a channel, right? That's
yeah, I think these wings.
Yeah.
Or something must slide in this channel.
And then there's a little step there, right? And that's where they kind of hold underneath. And so that's probably what's keeping the extended plunger
I see.
down, that little step.
Yeah, so let me point at it. This little shelf keeps them. This grabs the other side of this little part. It's nothing. This is like a quarter of a millimeter or something.
Yeah.
It's really nothing.
And then when you depress a different plunger, it seemingly pops that outward, pops the currently descended one outward.
Yeah, so here, these sides just keep it in place, I think. Just keep it in the channel. And then at the tip, I expect tip to do something with the other. Oh no, that's just where the cartridge is connected. The cartridge goes like this on top in there. No, it's not immediately clear how one releases the other. Interesting.
So it's okay.
Oh, I know. I think.
Yeah, hit me.
I think it's the back here, like one of these parts. Look, because if it's back here, and then it gets pushed by another, blink. That direction, boink. Then it can go back up again. So it's probably this or this part pushing against the other.
I think that the lower part of the wing, or the wing. I mean, the lower part of the trapezoid.
This one
pushes on. Yeah, that one pushes on the top part of the extended one, and that kicks it outward. So as you're
yes, yeah, sharp. That must be it.
Yeah.
So this part of, wait, let me get the second one. So what happens is that it's hooked behind here with this little thing, and then the second one comes like this.
Yeah.
And pushes it outward, and then it releases
and back up.
Goes back up. Yeah, that must be it. Nice.
Yeah.
we did it.
yeah. That was maybe the most satisfying. I feel like that was like, okay, we figured that one out. I'm still, yeah. But I mean, it's both very simple and I mean very complex engineering. Still kind of like a high degree of precision and
yeah, that's an underappreciated part of this, I think. Like these are all very simple mechanisms, and there's beauty in simplicity, and it's very smart. But I think we shouldn't underestimate the super precision that is needed to make this. A fraction of a millimeter, fraction of a fraction, and it doesn't work. It binds up, and super precise.
I mean, there's a lot of, some of the pen factories that I've visited, there's a lot of similarities in tools that they use. I mentioned this earlier, but to making like parts of wristwatches and parts of pens, you know, there's like a similar requirement for precision. And I feel like, you know, at least to my understanding, wristwatches are celebrated for their kind of like unbelievably meticulous, you know, detailed engineering, and you know, probably broadly speaking, they are more complex than pens, but there's still a lot of very complex, detailed engineering and precision required for a lot of pens.
Yeah, and especially the tip, of course. I heard, I did not fact check it, so maybe I shouldn't even be talking about this on a live stream. But I heard it took some countries quite a long time to be able to manufacture the tips of ballpoint pens. So I believe for quite a long while, like the bulk of the bodies and all the injection molding and all that kind of stuff was done in cheap countries. But the tips for quite a while were made in, because it's just so precise.
Yeah. That's so interesting.
Good. I think we should leave it at that for now, right?
Yeah.
Good.
Yeah, that sounds good.
We can close the stream, I think, Tingy.
Cool.
See everyone next time.
Yeah, thanks for watching, and thanks for having me, Aldo.
Yeah, it was my pleasure. I had a blast.
Yeah, me too.